So I'm making a video on these 30 days of Azure Databricks that this classmate did. So we'll see what he created. So Databricks is pretty common technology that's used. It's a recurring requirement in Azure data engineering roles. So he was doing a sprint on it, and he talked about how it's useful for Spark workloads, for data engineering, creating a Databricks workspace, mapping the UI, notebooks, repos, jobs, and data objects, checking workspace defaults, including default catalog. The key takeaway is it's an operating environment with a split that drives cost, security, and reliability. There's a control panel and has a data plane. And he said he would talk about clusters, configuration code, and VM issues. And then he asked people what's the most important common cluster mistake you can see from beginners. So that was his day one. On his day two, we talked about the Databricks cluster failing to start. The Azure code was the reason. He said that the hard way that the cluster setup is less about clicking buttons, more about understanding constraints and costs. Tried to add a worker in Databricks job, but his work quota so exceeded in this. Okay. Reduce the cluster to 4 cores, so if it's the quota, he's like, before creating cluster, check Azure quotas for the region and the VM family plan you plan to use. If something fails, start with the cluster event log, tells the quota capacity configuration. Pricing mental model. There's a total cost, there's a DBU cost with the VM cost. And on day three, he's going to talk about notebooks and utilities. Let's look at his day three. Notebooks and database utilities. He used notebooks before. Notebooks run the attached cluster, and some workspaces use serverless compute, multi-language per cell, magic commands like SQL, Python, Scala, make it easy to validate with SQL next to PySpark. There's built-in traceability. There's also version history and comments when collaborating, and there's a path to production. You can use database utilities, runs from Python or Scala notebooks, and cells, not SQL cells. There's a practical insight. The practical insight is that they explored the file structure using both %fs and database utilities fs, and then you'll be talking about Azure data lakes, Gen 2 and authentication options with access keys, SaaS, service principals, and cluster scope authentications. Okay. ADLS Gen 2 access failed, so it looks like he keeps running into failures. The fix was one permission. He worked on connecting Databricks to this Gen 2. Authorization is easy to set up and still wrong. He created a SaaS token with read permissions and ran this. It failed. Regenerated the SaaS, and then the database utilities worked. There's a fastest start highest risk for prediction. SaaS token has a service principal. He built an ADLS Gen 2 storage account containers aligned to bronze, silver, and gold. So he's like, oh, he'll be talking about Databricks secret scopes, Azure Key Vault, and database utilities. Let's see what's next. Secret scopes are the bridge between Azure and Databricks. Until now, he was embedding access keys in notebooks or cluster configurations, and that's how credentials leak. He moved to secret scopes back by Key Vault, created a key vault, stored a secret, created a key vault back secret scope in Databricks, and then in its case, sent it or uploaded it to the notebook and pulled values which database utility secret instead of hard coding it. Confirm the ADSL read works. Okay, he's gonna talk about DBFS and mounts. Okay. He probably did this through a hackathon, and then or like getting free database storage. So it's glitching out a bit for me here. I'm just gonna wait for it to start working again. Okay, it looks like I can move it. Okay, so why he's not building them? Enabled this file browser, upload a small task file, validate paths, find a key platform. Create this one of access luxury features. This access is exclusive of verbose. Mounts make access feel less like a normal file system path. There's a downside. Okay, Spark cluster architecture, data frame, and data source API. Okay. Yeah, the screenshot this time with Spark. Okay. Stop guessing how Spark runs. Spark UI makes it visible. Focus on Spark actually works. In Databricks, there's a performance and cost. There's an execution model, one driver, workers. Driver builds the plan and breaks an application into jobs. Spark parallelized by splitting data frames into partitions. Proof from Spark UI. Simple data frame action showed up as one stage. Vertical, bigger VM, horizontal, more workers. Okay. Bronze to silver in Databricks. CSV to Parquet with clear engineering choices. bronze, silver, step, and just CSV from our storage apply cleanup and write to process storage. Read CSVs with data frame reader API, inspected schema, selected filtered columns, rename columns, wrote, cleaned output data frame writer modules or modes. No infer schemes production with full by maximization partition with intent no habit can help query performance, can also create small files and overhead. Okay, he's moving on to bronze and silver. JSON pipelines break quietly when schema drifts. So you put guardrail, CSV injection is mostly straightforward. JSON is where things get real, nesting and schema drift. What else? CSV is flat, predictable, JSON's nested, flexible. TDL string for flat and stable schemas, structure type for nested or drifting schemas. Okay, design decisions. Ingesting multiple CSV and JSON files into one data frame. Single file reads to a more realistic pattern. Point Spark folder path, wildcards like this. Ingest too many files, there's an odd file that can break. Okay. Folder plus wildcard for repeatable ingestion, explicit files, need new files mechanism. Okay. Moving on to productionalizing notebook and Databricks, modular notebook shared config functions. What else? One big notebook to read something closer to production, modular code, reusable components, and schedule execution. Modular reuse with this pulls in a helper notebook, not copy pasting logic across notebooks. Parameterization, he's adapting database utilities widgets on the notebook to run across environments, workflows, and scheduling for production. Orchestration, he said it'll default to Databricks workflows. There's a run, which is useful when he needs to chain notebooks programmatically. Okay, what's on day 12? Spark filter and join transformations. It's two Spark transitions open almost every pipeline, filter SQL where, SQL style string. What else? Data frame style, better for maintainability. Join types, refresher. Cross joins. Okay. Two join tabs left, let me join. Keeps row from the left where match exists on the right. Okay. Left anti-join. Okay. Aggregate functions. Fastest way to turn raw data into decisions, focused on aggregate functions, Spark, backbone of analytics pipelines, KPI tables, basic aggregates, sum, average, min, max, grouped aggregations, group by egg, for rollups, Windows functions, small examples, total revenue per city, top 3 products, there's an aggregation with the partition, day over day revenue. Okay, what else? Accessing data frames with Spark SQL, temp users, global temp views. SQL says are great for readability, but one limitation is real. Can't cleanly pass Python variables into SQL cell. So you made a new view from a data frame, created in a SQL cell, created from Python using Spark SQL. Lets teams keep analyst friendly. SQL engineers keep pipelines flexible in Python. Session scope, restart or reattach when it's gone. Cluster scope, okay. How lakes become Spark files in Databricks. Connected storage at a SQL layer. How files in data lake become schemas, tables, and views. Data is files and object storage. Meta stores metadata. So Spark can treat those files like tables. Modern Databricks government is typically handled through Unity catalog. Unity catalog hierarchy. Catalog schema table view. Use, describe, extend to confirm table type. Okay. Manage tables. System manages metadata and data lifecycle. Okay. I might do a part 2 for this. It does have a lot of stuff that's being covered up until day 30. Oh, he's on day 26, so I guess I'll wait to do a part 2 and come back to this.